All right, let's look at limiting velocity. All right, so here's the situation. All right, let's say if you have a rock free falling. All right, of course, due to gravity, we have this acceleration of 32 feet per square second. All right, if we take air resistance into consideration, this air resistance is always the opposite direction of the velocity, and at the same time, air resistance is proportional to the velocity. So the faster you go, the more air resistance you're going to face, right? So, then we can set up a differential equation for velocity. So dv over dt is equal to, right, g, which is a gravitational acceleration, minus air resistance, k times v, because it's proportional to the velocity, right? So we have this differential equation, right? So what we want to do next is try to visualize this by drawing slope field using Geogebra, right? So let's look at this a particular example. dv over dt is equal to 32 minus 0.16 v, right? So let's sketch the slope field for this. All right, so using Geogebra, we're going to type in slope field. Slope field. All right. Oops. Slope field, just a square bracket. All right. Slope field, since 32 minus 0.16 v, so instead of v, we're going to use y. So 32 minus 0.16 y, right? Then I probably just put 20 and then hit enter. All right, so this is the slope field, and you can't see much, so I'm going to have to rescale a little bit. So here, I'm going to rescale this. I'm going to just put it right over the y-axis and drag it down, right, to change the scaling of it. And you can see that you can see a little bit better of what's going on here. So I'm going to just do it something like that. And then maybe I'll rescale here, right? All right, so this looks probably good. All right, so this is the slope field that you're gonna get. All right, so as you can see that maybe I'm gonna rescale a bit more and let's see if we can get something. Yeah, how about this? All right, so this is a slope field. All right, so if you want to sketch a solution curve, it would probably look kind of like this, right? So let's say, all right, so if you start from the origin, right here, right, which means that you're going to start at rest, then just follow the slope. So the solution curve has to follow that slope field. So you can see that the slope, following the slope field, your solution curve should look somewhat like that, right? So we want to see what happens to the velocity, as time goes by, right? So try to find a limiting velocity. But in order to find the limiting velocity, all you have to do is, you can see that the limiting velocity is around here. You can see that the slope is basically 0. So what you can do is we set this guy equal to 0. Then you can solve for v. And you see that the v is going to be equal to 32 divided by 0.16, which is actually 200. Right? So this is called the limiting velocity. So maybe I should. So this guy is the limiting velocity, right? Which is the answer to part A. Oops. Answer to part A. Oops. All right. And visually, so this is the limiting velocity right here. right? And if the velocity started out faster than, say, limiting velocity, say initial velocity happens to be 300, feet per square second, then what happens is that it's going to actually slow down and eventually stabilizes at the limiting velocity. All right, so let's go back to the Geogebra. Right, we can sketch this by doing so. Go to CAS, and we say solve ODE. Right, then you have 32 minus 0.16y, right? Then the location is 0, 0, right? So that's the initial condition, and hit enter, right? Then we can click on this circle, right? So you can see that this is the solution curve, right? And the limiting velocity, you can just type in y equals 200. That will be the limiting velocity, right? Then if you want to start from 300, all you have to do is copy this guy. Whoops. And I'm gonna copy this formula up here. Actually, can I just do this? Right. I'll just type in solve. All right. Solve ODE. Then you have 32 minus 0.16y. The initial condition in 0, say 300. Right. Then hit enter. Right. Oops. Hit and enter. All right. Then you click on that. Right, and it gives you another solution curve. You can see that it starts out the kind of fast, but it slows down and then eventually stabilizes at 200 feet per second. All right. So this is how you visualize, the solution curves, right? But the next question is, when will it reach the 95% of the limiting velocity? Right, so it's a 95% of 200. Would that be 190? Right. So what you can do is we can just type in y is equal to 95% of 200, so 190. Right, and click on that. Right. Then, so this is the 95% of the limiting velocity. Then all you really have to do is look for the intersection. So just like before, we just click on the line and click on the curve, and it gives you that. So it says that it's 18.72 seconds later, it's going to reach 190 feet per second. All right, so that's how so it's going to be, I'll just say 18.72. So the answer to this question would be about approximately 18.72 seconds later, it's going to reach the 95% of the limiting velocity. All right, that's it. I hope that this was clear.